Now that we oriented ourselves with global maps of sea surface temperature, winds, and precipitation and moisture fluxes, let's zoom into the tropics to start our journey into tropical atmospheric and ocean dynamics. Starting with temperature and humidity is clearly a good start because the temperature and humidity are what drive not only tropical circulation with condensational heating, but also global weather and climate. This is looking at June, July, August, December, January, February temperatures and specific humidities. No big surprise there, except now we are looking at the zonal section averaged over 5 north and 5 south. Typically, this is what is done when you want to look at equatorial features or deep tropical features. So these are longitude height sections now, and this is looking at specific humidity as well as temperature. Again, near the surface, warm temperatures across the globe. You cannot see clearly the upwelling regions because you have averaged 5 south, 5 north, and you don't see a tremendously strong seasonal contrast near the surface either, but humidities show that they are much more squiggly than temperatures because it's a variable that's responding non-linearly to temperature change. We will see something called the Clausius Kleperon relation, which is the exponential dependence of specific humidity on temperature. Warmer temperatures hold more humidity, of course. 1 degree temperature change will change humidity by 7%. Yes. So this is the height coordinate here in terms of hectopascal. In the atmosphere, height drops off from the surface to the upper atmosphere, so it becomes easier to do things in a height coordinate rather than a z coordinate. It also turns out that the vertical motions are better measured as pressure velocities rather than in meter per second and so on. This becomes clearer as we look at the dynamics. But let's see if you can identify the regions. This is the Indian Ocean sector. This is the maritime continent sector here. Here is the dateline. So this is the Pacific, East Pacific Galapagos region. You have the Amazonia here and the Western Atlantic into the Eastern Atlantic and so on. And you can see the impact of monsoonal circulations and seasonality of the rainfall over Africa and Amazonia here in terms of the changes in humidity levels and ups and downs. Okay, so is there much more to say than that? I suspect not. So let's look at zonal wind component and meridional wind components also averaged over 5 north, 5 south and along all longitudes in the pressure coordinate. And in June, July, August over the Indian Ocean sector, we see the strong monsoonal circulation. So you see the strong zonal winds of opposite sense in the lower and upper atmosphere, and over the Pacific you see also somewhat similar but not as strong a contrast as over the monsoon region. Again, meridional winds also show the monsoonal regime here with these continent land contrast kind of impact on the meridional winds, which have much more of a high spatial spatial variability feature than the zonal winds. So you can clearly see the trade winds kind of regime. Negative here obviously means easterlies from east to west, and westerlies the transition between the trades. And so here is the South American continent, the Atlantic trades, Pacific trades, and then you have corresponding meridional winds. And you can see that the order of magnitude here, this is going from -3 to to 3, whereas this is going from greater than -12 to greater than 10. So you have to be always sure that you remember meridional winds tend to be much weaker on average than the zonal winds, which has to be explained later on if you do the full global dynamics. How would you move energy meridionally if meridional winds are weak? It turns out mid-latitude dynamics are involved, baroclinic instabilities, failure of angular momentum conservation, and so on, which we will not get into in this tropical dynamics course. So upper level cross equatorial flow we had seen before, so you can clearly see the strong meridional winds in the deep tropics means you have cross equatorial flow that we talked about before in the regions where there is a strong convergence into the ITCZ. Okay, let's see. This is now showing vertical sections of winds. So this is the equator, 25 north and 90 east, and we haven't talked about the circulations yet, but this is already showing you that there is rising motion and convergence here in the warm pool region of the maritime continent, and you can see clearly the rising motion which hits the tropopause, goes east and west, then sinks over the eastern Pacific Ocean, and there is rising motion over Amazonia and sinking over here in the Atlantic sector as well. And if you go to 25, so on the equator, this is called Walker Cell. Sir Gilbert Walker, who was a British officer in the East India Company, was a mathematician, meteorologist, did many amazing things, including the Southern Oscillation, which turned out to be a critical part of the El Nino dynamics, which was not known for a long time after he had identified El Nino dynamics a long time after he had identified this pressure oscillation between Tahiti and Darwin and their relation to monsoon variability. And what else can I say? At 25 north, again, you have the East Asian monsoon, so convergence and rising motion, divergence and sinking motion over the desert regions, as you can expect, and over the ocean desert region as well. This is for June, July, August, and December, January, February. So you can clearly see the impact of the monsoon circulation here during June, July, August, which is missing during, or it shifts during the winter monsoon season. If you go to 90 east and look at the meridional section, so 90 east is basically in the Indian Ocean. You can see that you have a very strong rising motion and sinking over here at 30 south. So you have equatorial. So when you look at the zonal mean meridional sections, typically you talk about rising in the tropical regions and sinking of the Hadley cell at, let's say, 30 south, 30 north, and then you have other cells going further north and south. Whereas if you look at the 90 east in the Indian section, you expect that the equatorial region is going to be affected by the monsoonal circulation. So you can see a broad rising motion here with this sometimes what is referred to as local Hadley cells. So things get complicated. I don't want to deal with this too much here because it's better to see that, and of course that has a seasonal significant seasonal variability as well. So this is just a random section that Peter shows. So it's better if we come back to this with the dynamics and not just look at this in detail right now in the context of climatologies. So this figure has some other parts that I'll show in the next podcasts. So just try to get the 3D sense of the circulation. The trade winds, upper level circulation, meridional connections, which we haven't done yet in terms of Hadley cells, and the zonal connections in terms of the Walker cell, which we are introducing before we have done much of the Hadley cell yet.